Okay, so looking at section 5.2, it's entitled Verifying Trig Identities. Basically, a lot of what you've been doing in 5.1 was this, okay? So a good part of today is going to be working through some examples, but we're going to, before we get to that, I want to make sure that we kind of take a look at a few strategies. And your book presents these. I thought they were good. The last one was basically just a don't give up kind of motivational thing, so I cut that one off. But the first four that your book gives you are actually pretty good. But before we get to that, I do want to make a distinction and between two types of equations. One is a conditional equation. A conditional equation is the type of equation that we solve. Alright, it's an equation that's only true for some values of a variable. Okay. We'll run into these with our trig equations later on. You know, when we have tangent of theta equals 5, well, that's only true for certain values of theta. That's not always true. Okay? An identity, on the other hand, is an equation that shows a relationship that's true for all the real number values of the variable. So to see like a non-trig example, if I had 2x plus 5 equals 9, you know, a basic pre-algebra equation, we subtract 5 and get 2x equals 4, and then we divide by 2 and you get x equals 2. This equation right here would fall into which category? Conditional. A conditional. It's only a true equation if the x equals 2. Alright? However, I could have an equation like this. Alright, I could have 2x plus 5 equals, see if I can make this work out here, 7x minus 5 times the quantity x minus 1. Okay? If you were given that equation and asked to solve it, probably the first thing that you would do would be to simplify the right-hand side. You get 7x minus 5x plus 1. Or wait, hang on. Plus 5, yeah. I was going to say it didn't work. And then simplify it, you get 2x plus 5 equals 2x plus 5. So we got the same thing on both sides of the equation, which means this equation up here, the original one, is actually true no matter what x is. Okay, if x is any real number, 2x plus 5 will always equal 7x minus 5 times the quantity x minus 1. Now that's not a particularly helpful identity, but it's an identity nonetheless. It shows us the difference here. Okay? What we're focusing on right now in our study of trig is the identities. Okay? Getting used to substitute different values in, because as we saw before, once we get to calculus, substituting often makes things a whole lot easier. A lot of the formulas, a lot of the calculus formulas involving trig require some of these identities and things in order to derive them. So that's why we're spending a good amount of time working on these identities and using the fundamental identities that we've learned. Okay, so let's take a look at some guidelines here. Guidelines for verifying trig identities. First of all, only work with one side of the equation at a time. And just as a general rule, we usually start with the more complicated looking side first. Okay? Because if we can simplify it, we can get it to look like the simpler side. And a lot of that is just because, I mean, think about this one right here. If I have 2 cosecant theta, well, cosecant could have come from an infinite number of things. The trying to reverse engineer this to get from 2 cosecant to this whole mess is nearly impossible. However, if we take this and simplify things down, then we can get where we're trying to go. Okay, get to the simpler side. So I would say always start with the more complicated side first and simplify it. Okay, it is technically legal to work with both sides. The one thing you don't want to do is, you know, add something to both sides or subtract something. Don't treat it like an equation in that sense. But it is okay to simplify both sides, and then you end up with something that's the same on both sides of your equation. Okay. So, secondly, look for opportunities to do some of these algebraic things we've been looking at. Factor, add 2 fractions together, square a binomial, or create a monomial denominator. Remember we looked at yesterday multiplying by the conjugate of the denominator if you had 2 terms in order to get one of our Pythagorean identities, so that we could get it down to just 1 term in the denominator. And then that allowed us to split it up. Okay? So, algebraic strategies to simplify. Thirdly, look for opportunities to use the fundamental identities. And you're saying, well, duh, that's what we've been doing this whole time. The rest of this, though, is where it's particularly helpful. Okay? Note which functions are in the final expression that you want, and then also recognize sines and cosines pair up well. You know, for instance, sines and cosines pair up to make tangents and cotangents, or for the Pythagorean identity, secants and tangents pair up pretty well together, both in 1 plus tangent squared equals secant squared, but also because they both have a denominator of cosine. And likewise, cosecants and cotangents. They pair up well, both in the Pythagorean identity and in the fact that they both have sine as in their denominator. Okay? So, looking at those types of things and trying to work with them with that in mind can be helpful. Okay? So, if you have one that has secants and tangents in it, maybe you don't just automatically put everything into sines and cosines. Okay? Now, once you've kind of exhausted some of these strategies, and you can't see anything else obvious to do, the last thing here, try converting all the terms to sines and cosines, and that's something that we've done already a bit, but just want to reiterate. If you have any kind of a mixture of trig functions and you're not sure what to do, just try putting them all into sines and cosines. As we already saw back here, when we did that, hey, we ended up with a common denominator. And we were able to add those together. Doesn't always work, but it often provides us with a good opportunity to simplify, or at least will lead us to a point where we think of something else to do. Okay? Alright, so what we're going to do, and if you're watching the video, I'll show them briefly and you can pause it and then get the solutions off the PDF online. What we're going to do is we're going to take some time, similar to what we did yesterday, group up, work through some examples, and then we'll show the results. I'm going to give you a limited amount of time to work through them, and then we'll show the results, okay? So
there's nothing like new in 5.2, it's just like a revision?
there's really nothing new other than just distinguishing the term here, conditional equation from identity.
Yeah, but this, we need to practice a lot.
Yeah, we're going to practice a
Will
lot.
it give you-
And Tuesday, Tuesday,
Yeah, this, it's all fair game.
Will they give you any conditional equations, or you're just saying,
Not yet. The conditional equations are what we're building towards.
okay, cause then you can,
Solving
you can,
equations for theta.
so you can like subtract an axis from both sides, in a conditional.
In a conditional, yes. Okay? We're going to start with these two. For those on the video, I'll show this as the next two we're going to do. And then for homework, these would be some good ones to practice. Okay? So I'm going to stop the video now and we'll go back, start with this.